Imagine that you're a cowboy riding across the plains. With your horse, you're able to cover a certain number of miles when you're riding for a certain number of hours. You know that if you ride your horse for 3 hours, you'll be able to reach town, which is 105 miles away. But can you use this information to figure out other distances if you're able to ride longer, or if you can only ride for a shorter amount of time? If you're able to construct a ratio using the distance that you've traveled and the number of hours that you've ridden, you can grow it out or shrink it and find yourself a pattern. But that pattern can't tell you everything. For instance, how far can you get if you ride for 10 hours? Here, we can take the original ratio of distance over time that we knew from the beginning, 105 miles over 3 hours, and we can set it equal to one of the other ratios that we have in our table. You can use this proportion to find something that you don't know. In this case, the distance that you'll travel if you ride your horse for 10 hours. In order to solve this, we're going to have to employ a technique called cross multiplication. One thing you have to be sure of, though, is that across your proportion, you have to make sure that you're actually measuring the same things on the top and on the bottom. In this case, miles all across the top and hours all across the bottom. Likewise, you have to make sure that each ratio is consistent. For instance, on the left side of this proportion, we have our known quantities, how many miles we know we can travel in a known amount of time. On the right side, we have the variable that we're trying to solve, X number of miles for traveling 10 hours. Cross multiplication involves multiplying diagonally along the proportion. Some of you may have heard of this technique before, either called a ball and bat method or a butterfly method, but it's all cross multiplication. Multiplying diagonally, x times 3 gives us 3x. 105 times 10 gives us 1050. Solving for x the way we would any other one-step equation, we're able to see that x, the distance you can travel, is 350 miles. Let's say you have a flagpole that's casting a shadow on the ground. You know that the shadow is 10 feet long, but you don't know how tall the flagpole is. You can actually compare it to something that you do know. For instance, a 3-foot tall water fountain that casts a 2-foot shadow. If we're able to make sure we keep equivalent measurements equivalent, then we should be able to set up a proportion. We can actually make a table based on the fountain and the flagpole, each receiving their own row in the table, while the height of the actual object versus the shadow length each receive their own column. If we look at the fountain, we can see that it has a known height of 3 feet, and it has a shadow that is 2 feet long. The flagpole, meanwhile, has a shadow that is 10 feet long. Its height is still unknown to us, but we still have enough information here to set up a proportion. Making a proportion from a table like this is actually pretty easy, because all we have to do is transfer the numbers and keep them in their same position. Then we just draw lines for ratios and an equal sign in between them. If we want to find our unknown, all we need to do is use cross multiplication and then solve the one-step equation that results. 2 times x equals 2x, and 3 times 10 equals 30. If we divide both sides of the equation by 2, then we see that x, the unknown height of the flagpole, is 15 feet.